Now what I want you to do is notice that you just drew those 5 figures, a triangle, 2 quadrilaterals, a pentagon, and a hexagon. What I'd like you to do from the blue dots is draw something called the diagonal. A diagonal is a straight segment that goes from one vertex to other vertices in the same figure, and they're straight segments. They can't be on the surface of the segment, or on the surface of the shape. They got to be contained within inside the shape. Okay, they can't be squiggly things. And I'm hoping you're starting to figure out right now that I gave you an impossible task to do with the triangle, because you can't draw any diagonals from the vertex in the triangle. There's 0 diagonals. The quadrilateral, from that blue dot in both of them, draw your diagonal. That's all you're doing is that and this. Okay, so I've got one diagonal making 2 triangles. In the pentagon, I've got 2 diagonals. Okay, in the hexagon, I get to visit each vertex that I can reach with a diagonal. I have 3 diagonals. Now in the triangle, how many triangles are there? That might be a trick question. Do you see one triangle? So I got one triangle, 180. It's 180 degrees. Okay. In the quadrilateral, I've got 2 triangles, 360 degrees. In the pentagon, I have 3 triangles times 180. Are you okay with 540 degrees? How many degrees will the hexagon have? And this is interior angle values. The value of summing up the measure of degrees at each interior angle. So I have 4 triangles, each one 180 degrees inside. This is 720 degrees. Now, I could have you continue doing this and you started noticing, oh, Bloom's just adding 180 each time. You're starting to see other patterns, hopefully. But it comes down to the fact, I don't want you to be able to, or let me rephrase it. I don't want you to have to come up with a table to just figure out how many total degrees there is. There's got to be a shortcut. Because if I skip a few, say, hey, how many interior angle degrees does a 102-sided figure have? You'd be like, well, geez, I'm going to be here all day doing that. Well, let's talk about it. How many sides does a triangle have? How many triangles are made by a diagonal? In this case, 0 diagonals, but 1 triangle. How many sides does a quadrilateral have? How many triangles were made? Sides in a pentagon. Triangles made in that pentagon. 3. Is there a connection? Are you seeing the connection right now? Because I've got hexagons, a 6-sided figure, yet I have 4 triangles. So what's the connection between the sides and the number of triangles that are being made? Yep, -2. That's it. Matter of fact, that is the formula for the total interior angle value of a polygon. This is total interior angle sum. That's what it is. Total value of the interior angles is n minus 2 times 180. So our 102-sided figure has 100 times 180, because 102 minus 2 is 100. Okay, so it's 18,000 degrees. We'll total that. Okay, so let's talk about what we're doing today. We're talking about definitions of polygons, naming polygons, convex, concave polygons, equilateral, equiangular, regular polygons, and then we're looking at the number of sides and how we name them, and the interior angles and their exterior angles. Okay, because today's objective is to find the sum of the measures of interior and the exterior angles of polygons. So, starting off, maybe if this opens, I have the definitions of what makes a polygon here in page, 2, I think it is, that we start at. I guess that's page 1, I lied. Okay, so we got the definition right there on page 1. Go check it out. Now, part of learning about something is putting it to work right away. So after you write those things down, reread what defines a polygon and determine in 1A through F which one's a polygon, which isn't, and why. Why is it not a polygon? If it is a polygon, great. But if it's not a polygon, why not? Okay, go. Now keep in mind, a polygon is a plane figure that meets the following conditions. It's formed by 3 or more segments called sides, such that no 2 sides with a common endpoint are collinear. Okay, that means you can't break a side up into multiple pieces and say, well, that's like 1,200 sides below. Okay, because as long as it's a straight segment, that's one side. Okay. Each side intersects exactly 2 other sides, one at each endpoint. No 2 sides with a common endpoint are collinear. Vertex, the endpoint of each side, that's where the sides meet, and vertices is plural of vertex. Diagonal is a segment that connects 2 non-consecutive vertices. And now we're looking at the application of this, and we're talking about the fact that in A, everything's straight, connects, B, that as well, and C. But in D, it is not a polygon because it's got a curve. It's not straight segments. Okay. In E, it's not enclosed. It's not connected. Okay. And in F, the only time a side of a polygon is intersected is at the endpoints, not any time in between. So that's why I know what I know and when I know it. Okay. So make sure you start recognizing the basics of what the things we are doing. And now here's the big thing. The polygons, all of chapter 6 that we were working on, you worked on in elementary school. 3rd, 4th, 5th grade. Okay? We're doing some extended properties with them. Parallelogram, quadrilateral, kites, trapezoids, all that stuff we did in elementary. Identification of sides. Naming the sides of polygons with triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, all 3rd, 4th, 5th grade. Okay? Now, keep in mind, I'm very interested in you knowing all the names, the formal names, of sides 3 through 12. all the way up to dodecagon. After 12, I expect you to realize that n-gon, or like a 14-sided figure, would be a 14-gon. If you were truly interested in naming polygons, and that's what you wanted to do, polygon.com has a website you can look it all up on. Okay? Next page. Naming them clockwise. There's 16 ways to name problem 2. The first one. Because there's 8 places to start and 2 directions to go from my start. When you do name them, you name a polygon by listing the vertices in consecutive order as they're connected. So I want you to think in plain dot to dot. I go from A to B to C to D to E to F to G to H to name the polygon, or I could choose to start at H and go from H to G to F to E to D to C to B to A if I wanted to go clockwise like I did in the first one, or counterclockwise like I did in the second one. So I've come up with 2 ways to name this polygon. That's 2 out of 16 ways I can name this polygon. I just want you guys to come up with 2 ways each to name the last 2 polygons in this problem. But anytime you name polygons, you cannot crisscross across the polygon. Okay, you name them in order. You start at one vertex, you name them in order as you're going around, as if you're drawing the polygon for the first time. Now, after you name them, keep in mind, just because your name and my name are a different order, that does not mean you're wrong. When I check these, I look at your name, I start where you started, and I just follow it along. If I can follow along on the outside, you've named it correctly. If I can't, you haven't. And it's just that straight up. Okay, so I've got rat and tar. Okay, some people put art. That works. Any questions? Okay, so now, convex polygons. All vertices point outward in a convex polygon. Okay, all of them outward, outward. This is convex. A concave polygon, aka non-convex, only has to have one vertex that points inward. Notice, please, that this one has vertices that point outward here. But if I have one that points inward, it's concave, non-convex. Now, equilateral polygon and equiangular polygon we worked with before. An equilateral polygon, all the sides are the same. Equiangular, all the interior angles are the same. Okay, and incidentally, so are their exterior angles, because interior angles and exterior angles of a polygon are supplementary. There's one exterior angle at each vertex, and they're supplementary with the interior angle. And finally, if I have a polygon that's equilateral and equiangular, it's considered a regular polygon. Okay, so you've seen people talk about regular polygons. There's a lot of properties that we're going to study with regular polygons. But keep in mind, it's regular. If I tell you it's a regular polygon, all the sides are the same measure, all the interior angles are the same measure, and therefore, since all the interior angles are the same measure, the exteriors are as well. So there's that connection there. That's why I have just a tick arc all the way around that's the same in each. And then I have the single tick mark for the sides going all the way around because they are regular. Okay. Questions regarding regular, equilateral, equiangular? Because if it's equilateral, equiangular polygon, it's a regular polygon. Okay. Now, the names. I have it in a list. Polygons are named by the number of sides they have. Okay. So triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon. If a polygon has more than 12, use n-gon, where n is the number of sides. It could be the number of vertices too, because there's just as many vertices as there are sides in a polygon. Know these. They are on MCA, ACT, SAT. As a proctor of those tests, I cannot help you by telling you how many sides something has. Okay? If you go, well, what's a dodecagon? Well, we went over it in geometry. You got to know. Okay? They're going to test you on it. So make sure you're aware about what these are. And keep in mind, we've been doing these since elementary school. Okay? Now, how do I use stuff? The sum of the measures of the interior angles of an n-gon is n minus 2 times 180. We found that today. Okay, going through those first 5. How do I use it? Problems 3 through 5. Find the sum of the angle measure of each polygon. The sum of the angle measures. So the total interior sum, the total interior angle sum, n minus 2 times 180. Okay, how many sides do I have? I'll give you a hint. I would stop at this. Right? People are like, what do you mean by stop at this? You notice that all stop signs are the same shape, no matter what the state? Okay. N minus 2 times 180, where n is the number of sides. Plop it in. Okay, 8 minus 2 is 6. 6 times 180 is 1080. And that's how I'm doing this. Okay, this total interior sum. Okay, a dodecagon, use the same formula, find the answer for a dodecagon. Go ahead. If you need to, look it up. It's on the previous page. And then do the 36gon. Remember, if a figure has more than 12 sides, we can just use the number of sides with a dash and a gon right next to it. Now, 12 minus 2 times 180 is 1800. 36 minus 2 is 34 times 180. Okay, was it 6,120 or something like that? Okay, so we got those going on, but now we know the total. Okay, how are we going to use this in a problem? Well, look at 6. If I got to find the missing angle, I got people go, oh, Bloom, I can't believe you're doing this to me. But I'm like, well, what do you know? We got an application to figure out the total interior angle value of a polygon. Okay, we got the total. All we have to do is number up the sides. 1, 2, 3, 4, 5, 6 sides. 6 minus 2 times 180 gives me the number of sides total. So I got 6 minus 2 times 180 gives me 720. So I got 720 degrees. Total interior angle value. Well, to solve for x, I just add up each angle. And I evaluate. Let my fingers do a walking on my calculator and get it going. Okay? Or do it by adding up the whole row, the columns, and add them all up and find out. It's like 587. So after we add them up and say 587 plus x equals 720, I get to subtract my 587 and come up with x being 133. Okay, but keep in mind, I'm doing this because I know the total interior angle value, adding each angle up at where it's at, and then I can solve for missing values. Now, knowing that, check out 8. Let's look at 8. This looks pretty darn involved, but if we keep in mind, I count up the number of sides, it's 6. I pop it into n minus 2 times 180 gives me the total interior sum of my interior angles, total interior angle sum, okay? And I know that's 720. I now use my algebra skills to realize that, hey, this is 2y minus 20, 2y minus 20, 2y. There's 4 2y minus 20s and 2 y's, and I put that in as a setup. 4 times 2y minus 20 plus 2y equals 720. Because I know the total, I know the relationship, of the interior angles, and now I get to solve for y. Your turn. Solve for y. Get it done. You're in algebra land. This is what we always hope for. Isn't that 80? Right there, 80. Okay. So now we got 4 times 2, which is 8y, 4 times 20, which is 80, and then I got 2y here. So I got 8y plus 2y is 10y plus 80, or minus 80, I should say, and I evaluate. Should get 80 as I finish. Be careful. I get that mistakes get made. Practice making sure you avoid them. But this is the type of stuff you should be doing, and now you should be just checking your work instead of doing the work. Because if you're doing the work from the board, doing algebra stuff, we got to talk, because this is the basics. This is really, truly the basics for getting in here. Okay, if you're still copying my stuff when you're supposed to do it, start getting on your own. 7. It's your turn. I did an example that was much the same as what I want you to do in 7. Find the total interior angle value. Use the values that are already there to determine what the variables are using the total interior angle value. Set up a relationship. Get going. You got number 7. It's your turn. Get after it. Hopefully you know that a four-sided figure has a total interior angle value of 360. Then you got 2x plus 20, 2x plus 20, 2x and 2x. Well, that's 8x plus 40. That equals 360. And I solve and I get x is 40. Hopefully that went well for you. Are there questions on the setup? Questions on the solve? Any questions whatsoever? Now, keep in mind, we are applying properties. This is a lot like Chapter 5. Okay, it's definitions, vocabulary, properties, application, mathematically. It's just as much work. Please don't do just enough to get by. Okay, make sure you're successful. Make sure you make yourself do it. Make sure you do your assignments on your own on your time. Make sure you understand and you ask questions, because it's about you and future you's success. Okay, this test will be taken probably a month from right now. Okay, because we got that week off. We'll come back, we'll have a week, and we'll have another half week, and we'll take that test like January 12th, 13th. Okay, today's the 13th. Okay, Martin Luther King Day is the 15th. We'll review that week. The next week, finals. Done with semester. It's going to be that fast. Make sure you're ready for it. Make sure you're doing your work before we leave. Okay, so we've got this. Read this corollary to the polygon angle sum theorem. It's a corollary, which means it follows easily from. Okay, that's what corollary kind of implies. Please notice the red underlining under the word regular. This formula only works for regular polygons. What does regular mean in a polygon? I'm talking about regular, it means all the sides are the same, but in this particular case, because we're talking about angles, all the interior angles are the same. And so are all their exterior angles. So when I'm saying it works for a regular polygon, I'm just finding the measure of one angle in this case, because I take the total, divide by the number of angles that should be there, because that's the number of vertices or sides, and I'll get one value that's the angle value, one solitary angle. So when I'm saying this, when I use this, I'm asking you to find the measure of one angle in each regular polygon. This is so huge. It's got to be a regular polygon for this to work. Okay? So I've got a 5-sided figure. I use that formula. Plop 5 in. Go. Get it done. We are finding the measure of one interior angle. Okay? Must know what you're finding when you use it. Otherwise, you'll do it incorrectly, and that's not pretty. So 5 minus 2 times 180, that's 3 times 180, it's 540, divided by 5, 540 divided by 5, 108 degrees. It's a 108-degree angle. That means one angle is 108 degrees, one interior angle. What's the exterior angle to that interior angle in this polygon? Remember, in an exterior angle, it continues one side out, and there's always one exterior angle at each vertex, and they are supplementary with the interior angle. So an exterior angle in this case, 72, because 108 plus 72 is 180. That's going to be a significant piece of information that we're going to use a lot. Okay? What I would like you folks to do at this time is to find the measure of an interior angle in problem 10, a hendecagon, and in problem 11, a heptagon. Go ahead and get those two done. If you need to, look up the names on the front of this sheet so you can know what your n value is. But this is practice. You should be done with these before we move on. Check out the number that we'd be using and see what up. See what up. Hendecagon, 11-sided figure. 11 minus 2 times 180 divided by 11. 11 minus 2 is 9. 9 times 180 divided by 11. 147.3 degrees. Okay? Are there questions about what we're doing? How we're doing it? What's happening with it? How is it going about? How many sides does a heptagon have? 7. 7 minus 2 times 180 divided by 7. Get it going. That's all I'm doing. You should be getting this figuring done all on your lonesome. Yep. It's a heptagon on 11, so it's, well, how many sides is a heptagon? 7, so 7 goes in on the bottom because it's the number of sides. So on this one, we're talking about, this is 7, this was 11. That's why 11 went in there, and 11 minus 2 came out to 9, and 11 went in there. Here, this is 7. 7 goes in here, 7 goes in there. And I got 5 times 180 divided by 7. So I've got a 900 divided by 7. That's got 128.6 degrees in my interior. Now remember, I'm finding the value of one interior angle doing this. Okay, if you're not sure what you're finding when we're working with this, we're going to have problems come next year when we actually take the test. Okay, no, it's a long time away. It's a whole year. Okay, now keep in mind I have 2 items left. I talked about the exterior angles. Exterior angles and interior angles in polygons are supplementary. But now, here's the deal. Exterior angles, one at each vertex of a polygon, any polygon, total, completely, always, to be 360 degrees. Every exterior angle add up to 360 degrees total for any polygon. I got a 36-sided figure. The exterior angles will sum to 360. So if I have a 36-sided figure, how many degrees is my exterior angles if it's a regular polygon? There's 36 sides. I take the number of total angle degrees and divide by 36. What's 360 divided by 36? Are you okay with 10? Wow, that's 10-degree exterior angles. Now, if an exterior angle of that figure is 10 degrees, and the exterior angle and the interior angle are supplementary, what's the interior degree? 180 minus 10, 170? Pretty high-tech stuff now, right? We're able to do a bunch of stuff with that relationship. So the first thing I want you to do is find x. 4x plus 2x plus 2x plus x plus 3x all equal 360. Okay, solve. Get your solve on. See how you doing. See how you doing. Now I got 12x equal 360. X gotta be 30. Just done. It's 30 degrees. Maybe if I get it in there. Apparently I got rid of it. X is equal to 30. Now keep in mind, I can take that 30, plop it in, find that that's 60, that this is 60, that this is 30, that this is 90, that this is 120. More importantly, the interiors, 60, 120, 120. If this is 30, this is 150. That's 90, so is that. Crazy, I can find the interiors based on my exterior angle values. Okay, in a regular figure, the exterior angles is the same all the way around, because every one of the interior angles in a regular polygon are the same. That means every one of the exterior angles of that polygon, regular polygon, must be the same. So we have a corollary. The measure of each exterior angle of a regular polygon is 360 divided by the number of sides. So here I've got 360 divided by the number of sides, 8. I get that that's 45. 45 degrees is the measure of the exterior angle. Because I have the measure of the exterior, hey, I could have a second part of this question. What's the measure of the interior angle of this polygon? And everybody's going, well, I've got 180 minus 45. Well, that interior angle, Bloom, would be 135 degrees because they're supplementary. Done. Okay, now, how are we going to use this today? How are we going to manipulate those properties to find answers? Check it out. Read the question. Don't assume you know the question. Read the question in its entirety. Find the sum of the measures of the exterior angles of each regular polygon. Round the nearest tenth if necessary. Okay, we just found out that there's a limit to how big exterior angles have to be. Exterior angles will sum to the same value all the way through. And what is that value? 360. So in a decagon, they're 360. In a hexagon, they're... In a square, it's 360. In a 60-gon, it is 360, crazy. Well, that's all the same all the way across. I've had people miss that on the test, folks. It was even in their note card because they didn't know what they had because they just didn't know what their note card said. Make sure you reread your notes. Make sure you are aware of your properties there. Next one, find the measure of an exterior angle of each regular polygon. Just one angle? Yep. Round to the nearest tenth if necessary. So if the total is 360, divide by the number of sides and you'll find a single solitary value. This is the formula I'm going to use. People are like, are you kidding me, Bloom? You're just going to go 360 divided by 10? And you're going to come up with 36 degrees, and that's the measure of the exterior angle? One of them? I go, yep. And you know what? There's a connection, the Bloom corollary. If I know the measure of the exterior angle, I can actually tell you how many sides something has. Or if it has enough sides to make a polygon. Because if it goes in evenly to 360, it not only will make a polygon, but I can find out how many sides it has. My example, if I know the total is 360 and I know my exterior angle value is 36 degrees, I get a 10-sided figure. Okay? If it doesn't go in there evenly, it doesn't make a regular polygon. Okay? Kind of neat. Be able to know that just by doing a little check. So your turn. Find 19, find 20, find 21. Go. They're quick. They're fast. They're unbelievably quick. Make sure you're aware of the property that you're applying. Okay? So in a hexagon, I got 360 divided by 6. Are you okay with 60? In a square, I've got 360 divided by 4. 90. That's my exterior angle. Hey, in a 60-sided figure, I've got 360 divided by 60. The exterior angle is 6. Crazy, right? Now, go to the next question. Check it out. I want you to know about the relationship between interior and exterior angles. We've already talked about that they're supplementary. Well, I'm asking you to use the idea of them being supplementary to help you get the answers to these things. I just want you to do 22 to 25. I want to hold off on 26 through 29 for next year. Okay? We're going to do those next year as a review when we get back. Don't just do them now because people who don't review them next year really have a hard time with that quiz. Okay? So, know that if I have the exterior angle, like 12, I subtract it from 180, I'll get 168. If I have the exterior angle, 12, and I divide it into 360, I'll find the number of sides. And look, the number of sides right here, number of sides, 360, oh, 12. I got 30 right there. I've got it written down. But in this next one, I'm doing the same thing. Okay, and number 23, 180 minus 6 is 174. Well, 360 goes divided by 6. Well, that's 60. That's got 60 sides. Crazy. Do the next two. Now remember, I've got some people thinking today, oh, this is way better than chapter 5. I had y'all thinking on that on section 5.1 and 5.2. This is way better than chapter 4. It's not about today. It's about next year, a month from now when we're taking this stinking test. So make sure you leave yourself good notes, a good trail of notes to review from. Okay? Hopefully you're recognizing how to get this done quickly. Now, we got that. 26 through 29, same stuff. Don't do it right now because we want to make sure that you remind yourself. 30 through 33. Okay? Looks like it's just a horrible, horrendous thing. But 30 through 33. Read the question. Look at my example. Figure out what I did. and repeat it. I just want you to do problem 31 because we're going to hold off on 32 and 33 for next year. Look at what I got. Figure out what I did. Replicate it. And then do it in 31. I give you information. Let's see what you know. Are you okay? At 60 and 6. Okay? Folks, make sure you're doing your assignment. Make sure you gets it. Okay? Make sure you're getting it done. I know you have like 4 minutes for today. But I also know that first page will take you 4 minutes. Okay? The second page probably takes you 10 more. Okay? Thanks for your time. Make sure we're getting things done because only you can help yourself be successful completely and totally for future you to do well in the final. See you soon.